Let me make sure I'm muted.
Good morning and welcome from the MLC Coffee Chat. I'm Don Watsa, an MLC Events team volunteer. Thank you for being a continuous learner and attending today's event. On behalf of the MLC, we're glad and grateful you're here. As a reminder, the MLC has many learning opportunities to look forward to. We have book clubs, coffee chats, Gemba walks, annual and conference meetings. So if you pull up your calendar, be sure to include on your member event calendar the member thank you event, November 2nd. And you can find these and all the activities at michiganlean.org. So the plan is to end today at 9:30. So grab your coffee and let's go. Today, our presenter is Beth Crowley of Crowley Group and a celebrated Oakland University teacher. I'm fortunate to have had Beth as my instructor in 2018 in the graduate Lean Learning program at Oakland University. So I've known Beth for a while and appreciate her work. I've actually had an opportunity to work with her a bit and find Beth to be interactive and fun. And so hopefully you experienced the same this morning. So Beth is on the faculty at Oakland University School of Business and a regular contributor to the digital magazine, theleanmag.com. She has a comprehensive hands-on background in all aspects of executive coaching, change management, process reengineering, value stream optimization, and team leadership. She has extensive domestic and international industry experience and consulting in both manufacturing and corporate. If I pull from our LinkedIn experience with Beth, she's been with Stroh's, Unisys, Honeywell, Whirlpool, and a number of consulting companies. So with that, Beth, take it away.
Good morning, everybody. Thanks, Don. I'm Beth Crowley, as Don said, and I've been doing lean type activities since the 90s. Before there were belts, before lean was an industry, I was out there doing total quality and cycle time reduction with Allied Signal. So I got a great view of the business and how to do lean before anybody was really talking about it. I'm really passionate about it. I love continuous improvement. I love coaching folks through that journey. So today we're just going to talk about Takt Time, and I'm not going to go into real detail. It's kind of a high level just to understand what the concept of Takt Time is. And here's our agenda for the day. I don't mind if you interrupt me. I've asked Don, because I'm not in the room with you, to see your faces and see if you're raising your hand or you want to say something. I've asked Don to really monitor that chat. So if you have questions as I'm going through, you want me to go faster, you want me to go slower, you can yell it out. I won't be offended, or put it in the chat and Don's going to tell me. So hopefully that works for everybody. And the first thing I really want to know once I run through this agenda is, what do you hope to learn today? I was just talking with Andy and Jane earlier, and I said, I've got slides together, but if it doesn't take into account what you guys really want to hear, then we'll just stop and we can talk about whatever it is that you want to talk about. We're just going to talk about lean thinking and Takt Time, just how Takt Time fits into overall lean thinking. Then we'll just basically have some examples and have some discussion about when it works, when it might be more difficult. I'm a real practitioner of the real world, so I'm not hard and fast that you have to use this exactly the way it was intended, and we'll talk about that going forward because we don't live in a perfect world. So we may have to make modifications, but it's about the concept and what you're trying to do. So I believe in honoring time contracts, so I'm going to end by 9:30. If we have 5 minutes at the end, I'd just like to get your feedback on how we think the session went. What did you like? What didn't you like? Et cetera, so that I can do better the next time that I do it. So with that, are there any questions, comments, and what do you hope to learn today? And if there's nothing specific, that's okay too. I'll just kind of go through my presentation.
Beth, I don't see anything in the chat yet. So I'll keep
Okay,
monitoring.
excellent. Then we will just start rolling forward. So in my opinion and other people's opinion, Lean has kind of turned into an industry in itself. And there's all kinds of implementation strategies that, I think we should do this first. No, you have to do this first. No, but I was successful doing this first. I don't care about that kind of stuff. What does it make sense for your organization to do? Okay. But it can be confusing if you've never done this before to really think where is the appropriate place to start. And one thing that most Lean practitioners can agree on is Womack and Jones and the machine that changed the world and Lean thinking. And the whole idea of creating value for the customer, creating flow, and pursuing perfection. So Takt Time really fits into creating that flow, because you say, okay, I can recognize that we all want work to be moving because you don't make any money when it's sitting around like inventory, or you have to pay for it. You have to move it out of the way. You have to count it. You have to pay taxes on it, et cetera, et cetera. So everyone can agree that it's so much better if you can get inventory in the house, turn it into something else, and get it out as fast as possible. That's the best way for your working capital to make money. But then the question is going to be, okay, so we want to create this flow. At what rate should we create it? How fast does our process need to flow? So in a perfect world that we know doesn't exist, though, but the goal, smooth, consistent flow of work synchronized throughout the supply chain, right? That's the perfect world. That's the Lexus tagline of the passionate pursuit of perfection. Nobody's waiting. There's no inventory. There's no waste. All suppliers deliver just in time. Again, perfect world. I used to argue with systems type people because I'm an operations type person. And they'd say, well, if you could only do what the system says. No, if your system can match our imperfect world, that's what we need right now. As we get better and better, then we can improve the whole system. So what speed again? What speed do we want things to go through the process? So the speed with which product needs to flow is equal to customer demand, and that is the concept of takt time. Takt time says, how often does a customer need a product? Then that's how we're going to base our whole process, our whole system. So if you look at the supply chain graphic on the slide here, basically it's telling you from the customers to retailers to wholesalers to the manufacturers to the suppliers, we all have to be beating to the same drum, whatever that takt time is, right? So how do you figure out what takt time is? Takt time is that beat. I know some of you got I think I'm funny with my Go-Go's references, but that's really what it is. What is the beat of the system, right? How often do we have to do things in order to meet customer demand? So the formula is really simple. It says, how much time do you have and how many units are required? That will tell you what your takt time is. And your takt time is going to be minutes, hours, days. It's going to be some kind of reference of time, right? Takt time. Takt is a German word. Don knows I talk about this a lot. I'm not in favor of using words that some people can't understand. I would probably call it a drum beat when I'm implementing something like this. But in your organization, you can have obviously your own philosophy on how to do that. But it makes people a little nervous because they look at the word takt and they don't know what that means. It's because it's a German word. We're not supposed to know what it means, but it means that drum beat, right? So what it means, how often a product must be completed to meet customer demand. It's the time available to produce a component or a single unit. And it's also the time between final part completion. Let's say our takt time is 10 minutes. That means that I know every 10 minutes there should be a product ready to go out the door, right? I know that I've got 10 minutes to complete whatever it is that I need to complete at my station to move it forward to keep us meeting our schedule. So that's what takt time is, just the beat. How fast does product need to come off the end of your line in order to meet customer demand? Any questions with that? My little orchestra conductor over here, right in the corner, he's keeping the beat for all the musicians, just like all the operations in a process would be.
Beth, at the moment, no questions in the chat.
Okay, thank you. So let's calculate out takt time for very, very basic high level information, right? So I put our formula up against in the corner so we can refer back to that. And then I've got plant data for some plant, right? So their shifts are 8 hours and their production goal per 8-hour shift is 84 units. So we've got some planned downtime per shift. We've always got to take into account breaks and lunches. And this plant is doing some preventative maintenance every shift. So they got 10 minutes for that. So basically you say, okay, there's an 8-hour shift. So that's 480 minutes, right? You got to take out that planned downtime of an hour, the lunch breaks and the PMs. Divide that by the 84 units per shift that's required per the customer, and that gives you 5 minutes per part. Okay, so what does that mean? That means that every operation in the system, in the process, should be ready to receive new material to process every 5 minutes. It also means that every 5 minutes, a product will be ready to ship. And it also means that the work content of each operation must be less than 5 minutes. So what that's saying is that the amount of time that it takes each station or each person or whatever it is along your assembly line, each person or station, the work content has to be less than 5 minutes in order to keep everything flowing at the takt time of 5 minutes per part. Does that make sense to everybody? We're going to go in a little deeper. So let's look at this graph. And let's talk about cycle time versus takt time because they're very different, right? Cycle time is the time that it takes to complete the work at this station, right? That's where the work content there, that's your cycle time. And then your takt time, again, is completely different from that. Takt time says, how often do we need to make a part to make our schedule, to make our customer happy? So in this graph right here, let's say it's a sequential assembly line, right? And so there's 5 stations, there's 1 operator per station, and their takt time is 5 minutes. Based just on this graph, is it possible for this process to deliver on time?
No.
No. Why not? Thank you for answering.
Because your cycle time's over your takt time in this particular case.
Exactly. What do you think station 2 is doing all day?
Standing around waiting.
Standing around waiting. Where do we think the inventory is in this process?
Station 3.
Station 3, right before station 3. Absolutely. Because as soon as station 2 is getting something, boom, it's going right to station 3. And we can tell by this graph that station 3 can't be on time regardless. So every product that goes by, station 1, station 3 are getting behind. Station 4 might not be getting behind only because station 3 is slower than it is, right? So this is, to me, the first time I did a takt time project, it was this kind of graph that made like the aha bulb go on over my head. I'm like, oh, so I have to take some of the work content from stations 1, 3, and 4 and move them to stations 2 and 5. And if there's still too much time, then maybe I have to add another station or a half a station or whatever else it is. Okay, so this right here to me is a good graphical representation of what takt time does. Any other comments or questions? All right, so I'm going to show a quick video that just kind of shows this like an unbalanced process in effect. Now, some of you are probably, I haven't seen all your faces. Some of you are old enough to remember this video clip, I'm sure, and probably many of you aren't.
Beth, we can't hear the video.
Oh. Can you now?
No, we still don't hear it.
I think when you share your screen through Teams, you have to click share share the computer sound.
Let's see if I can.
Yeah, we had this worked out ahead of time.
Is it working now? It's still not
No.
working.
No.
I can't hear any of you guys now.
We can see the video, but we can't hear the audio.
Can you hear me talking?
Yes.
Yes.
Okay.
Yes.
It's okay if
Maybe
we
you
don't
should
see
narrate.
the audio. I think the point, right? We can see the point that they cannot, they can't make this work. If you think about the conveyor, now I can't even, okay. If you think about the conveyor as moving at the speed of takt time. You guys see my screen again with the graph?
No.
No.
Now we see you.
I swear we practiced this.
Yeah.
Did you guys turn off the audio?
Hold on. I did because of how we've hooked up. Sorry about that, Dan.
That's all right. So the point of that was to kind of to see the chaos and the fact that their cycle time, the amount of time that it took them to do their work was greater than what the takt time is, what the conveyor speed was set to. And they actually speed it up in the end to make it even worse, basically. So they just, because the woman there, I know you couldn't hear it, but she's like, oh, you're doing great. Speed it up. And they had already been shoving them in their mouths before that, just to make the conveyor speed, or just to make it seem as though they were hitting that time. So basically they were overburdened, like this graph shows, and you would have to readjust, move, and balance that work to a different area. So in the Lucy and Ethel, you couldn't really tell, but each one was doing the whole process. Their process was just to wrap the chocolate and put it back on the conveyor. So each one of them was getting behind because that was the total work content was too much for how fast that conveyor was going. So if you think about it as sequential stations, right? And let's say the takt time is 20 seconds, but the total cycle time for all three, for the whole process, is 60 seconds. So that's when you would add a third person to the or a third station or whatever it is, because you have a 20-second takt time, you had about 60 seconds in the cycle time, divide that by 3, and you've got your 3 stations that can stay at or under that 20 seconds. So that again, at the end of the line, one product is coming out every 20 seconds. And along this line, all of these operators know that every 20 seconds, their feeder operation is going to give them something. So they've got to be giving their product on to the next station. Does that make sense? Any questions? Okay. So I'm not going to show another video, but The Big Bang Theory, I think it's a funny show. And one of their episodes, Penny is making these penny blossoms for her hair, and people are buying them. And of course, Sheldon comes in and says he wants to help her optimize her manufacturing process. So when they're actually singing a little song in the video, and you can kind of tell in these pictures, that's keeping them on the beat. So every time they get to the end of the stanza, they know they've got to send that product to the next little station in their assembly line. So I like to try to show, you know, kind of real world, or would have been entertaining had we been able to see it. So then let's talk about implementation of Takt Time, right? So there are limitations to this concept. And one of the big ones is that it's got to be mass production of a fairly standard product. It's really hard to get your whole supply chain focused on whatever the drumbeat is and when they need to supply parts if you don't even know what those parts are going to be, right? So it's got to be fairly standardized products. It's not for highly customized products, job shops, anything make to order, like custom suits. It's got to be something where the component parts are interchangeable. That means it doesn't have to be this part goes on this car and this part goes on this car, right? It's got to be able to just be interchangeable. They've got to be standard enough, those parts, that we can use them on any final part. The process has got to be repeatable. There's got to be drawings. There's got to be standards. There's got to be tolerances. Again, for highly customized parts or products, you just really can't you can't do this to the letter of the law. You can figure out a way, because there's still going to be kind of a drumbeat of how many products are coming out at the end of your process. They just might not be standardized enough to completely go back all the way, like in this example here, to the lumber company and tell them, you know, with certainty that this is going to be what I need 2 weeks from now, 4 weeks from now, whatever it is, because it's so highly customized. So the product can be complex. You know, a car has like 30,000 component parts to it. And that's okay. You could still use Takt Time, because you would just have to figure out for different models or whatever your base car or your base model is, and use that as your average, and then have a little bit of flexibility in that timing. So once you determine what that Takt Time is for your final product, all of the internal and external supplier operations must be synchronized to that rate. Okay, that's what we're talking about. What's the drum beat? How fast do you need more, right? And it really, you have to keep that rate constant for some period of time, for some planning horizon, so that you know that all your suppliers up the supply chain can react fast enough if you do need to change it for the next month or whatever it is. So lead times obviously are very important too, for how long does it take for you to get all of the parts that you need.
So Beth, I'll just ask a question. What's the best time interval, and how dependent is it? Like, what have you seen? Like, oh, we'll change Takt Time every day, week, month.
Oh, I would say like a month would be the shortest amount of time. It's kind of like your planning horizons in your MRP and whatever your process is. You would probably set it at whatever your frozen schedule, you know, then your less frozen schedule. There would have to be kind of a date that it locks in, so that you know what parts to buy. Does that make sense?
That does make sense. We have a question in the chat. Can you explain
Great.
product? Can you explain product complexity versus standard product again?
Yes. Product complexity, what I mean is that there can be a lot of component parts. It's the process that can't be complex and custom. So again, if you have we're going to talk about Willow Run in a minute, right, as a big example of using Takt Time. And in the days of Willow Run, there were 15,000 car parts in each car. And that's what Henry Ford was used to making, right? But he still was able to standardize, because back then they were the same parts pretty much. When he went to start building the bombers at Willow Run, there was 1.2 million parts in a bomber. But that is not what complicated the process, because you can set that up as long as the parts are relatively the component parts are relatively standard, or if it takes the same amount of time to assemble them, you can build that into your process. But the process complexity is not okay, where it changes all the time. Or as an example, I worked at a job shop where we were machining the parts for plastic injection molding machines. So it was an MRO part, maintenance. We had no idea, and it was very specialized per piece of equipment that it was going into. So we could, get our parts to a certain vanilla stage, right? But they could be made into a lot of different things, but there's no way we could have set a takt time that said we need a part every 10 minutes, because number one, our orders came in completely random. It's when a part broke, right? So that's why we actually figured out that we could hold the stock, machined to a certain point that could then become a lot of other things. But we couldn't say we were going to be done, that we were going to have 2 parts done a day, because everything was so highly customized. Does that help?
So we have yes, the person said they got it. We do have another question about a limitation.
Mhm.
So would another limitation of takt time be highly specialized / trained staff who are experts at one thing only? So a staff training question.
It may not be a limitation of takt time necessarily of implementing that. It would make it more difficult, because if you think about, if we go back to one of these kind of slides, right? If your station 2 person doesn't know how to do station 1 stuff or station 3 stuff, it makes it difficult to balance the line. Does that help the question, or did I not answer it?
No, I think that would certainly answer it for me. Sam, if you have a comment, feel free to put it in the chat or ask.
I have a question.
Sure.
Do takt time and just in time go hand in hand?
Takt time would be the rate that you set your whole just in time to.
Okay.
Does that make sense?
Yeah.
Yeah.
Okay.
Again, that's that perfect world, right? Where I take exactly the amount of time that I'm supposed to take, and so does everybody else.
Okay, thank you.
Mm-hmm. Any other questions?
No other questions in the chat.
All right. So, and this is the big example that I'm going to use today, and it was really fun for me because I've done a bunch of research about Willow Run and what went on there, getting ready for this presentation. So that was kind of fun for me. I watched a bunch of videos and I read books, and now I want to go to the museum. But Willow Run was designed around an idea of a bomber an hour, okay? And it really was because President Roosevelt, the United States wasn't even in World War II yet. And President Roosevelt was like, we need 50,000 bombers to help support the Allies, because otherwise they're getting crushed over there. And the company in the United States that made most of these bombers was Consolidated Aircraft Corporation, and they were making 1 a month. So clearly, you don't have to be a genius or a manufacturing genius to figure out that we're not going to get that 50,000 out of Consolidated. So President Roosevelt asked his advisors, who are the big industrial manufacturers that we have in this country? And they went to the automotive industry because there was mass production. They actually went to the guy who was at GM, Bill Knudsen, and he got Henry Ford involved. And basically, Henry Ford sent his manufacturing guy out to Consolidated was also in California. So his head manufacturing guy went out to California check out their operation, see, you know, maybe he could help them tweak a little bit more out of it because we were good, because the automotive was good at mass production. So he went out there and he looked at what they were doing, and they were basically customizing every single bomber. Every part had to be retrofit probably into, they were probably shimming things. We didn't know how long it took to do one. There were no blueprints for the bombers. It was basically like a customized tailor making suits. So even if you think about training for flying these bombers, everyone was a little bit different. So the Ford manufacturing guy said, I can't help you. This isn't. And so the president of Consolidated said, okay, smart guy, how would you do it? And he said, I don't know, but I'll tell you tomorrow. And he went home and he drew this schematic that's on the top here. The top graphic was his original drawings about how this whole process could be set up. And he even said that next day, and we're going to make one bomber an hour. So Ford had some issues when they started up, because like I said, there were no blueprints. So there were no tolerances. There was no, it was very much these limitations is what a lot of things that they ran into when they were trying to get this up and running. And no one other than the Ford guys thought they could do a bomber an hour anyways. So they were like, see, we told you it's never going to work. Well, they said, but you keep changing the design every 5 minutes. How are we supposed to do that? So they started freezing the design like model changes in automotive. And all of a sudden, they were able to hit that takt time. They didn't call it takt time at the time, but they were able to hit their rates, and they were actually making, they said because they had two assembly lines next to each other, and every hour, maybe every, two of them were being driven out the east doors and flying away. And that was, you know, it took years and years and years to get there. But basically this slide right here shows how they set up that assembly line. They said, okay, we're going to move it. And they built the whole building and all that kind of stuff too. The assembly lines were more than a mile long, but they had two assembly lines next to each other going straight down. And every one of these stations that were feeding it had to have a takt time of an hour or less, right? So if you look at the parts list, they need 4 props. So they need 4 props every 60 minutes. So they needed one of those every 15 minutes in order to supply the assembly line. So that's up on the top left, the red box, right? 4 required. So the takt time there is 15 minutes. So each one needed one forward fuselage. So up on the right side, said you only need one. So the takt time for the forward fuselage was, again, 60 minutes. They just needed 1 hour to feed the assembly line. And then on the bottom, as an example, they needed 2 rudder subassemblies. So the takt time on those is 30 minutes each to get us to 2 an hour to get to the line. And then 6 ribs were required per rudder. So again, we need 6 times 2. So we need, 6 per, so we need 12. So that takt time for the ribs was 5 minutes each. And this is just an example, obviously, of a few, but then you would have to go back to your external suppliers as well, right? And add lead times in. And it's kind of in backwards schedule to say, okay, if it takes you 4 weeks to get whatever we need here, then we need you to come in this often because we have this much space to store it and we need it to replenish, and we need always 1 an hour or 4 an hour or 12 an hour, whatever the component part is. We've got to feed that assembly line. So this is just kind of, I think, a pretty good visual representation of the assembly line moving forward and all of the feeder operations and how it's all moving to that same drum beat, that same conductor with its orchestra or whatever it is, or the song that they're singing. Any questions or comments?
I got a question.
Beth, I'll just throw in. Oh, go ahead.
Go ahead, Don.
Well, I'll kind of add some meat on the bones. I've been following behind Beth's work and sharing some of the stories. So I was reading last night, Charlie, this is Sorensen, had 1,000-member, I'm reading the quote, 1,000-member tool design group worked around the clock 7 days a week for almost a year to create three-dimensional schematics of the plane's 30,000 separate components, generating, are you ready? Wait for it, 5 million square feet of blueprints in the process. I mean, and when you go back, you read that, oh, supervisors had the information. And there was this very very, very inconsistent, undocumented method of building the planes in California. And so I just find it fascinating that they did that level of detail to get that to happen. So, sorry, other question?
Yeah, no problem. So I'm at a job shop. We've been using Takt Time for 3 years now. We've kind of adjusted, but there's still times that is very difficult to compensate for setup time because multiple setups happen in a day on a machine and they could vary. Is there any tricks on how to kind of group that in there to be able to account for that? Or
can you get like to the 80-20 rule where 80% are relatively similar and then 20% is not, or they all vary?
every
different?
single part unfortunately varies. There's product family that kind
Yeah.
of like, okay, this time ranges between 7 minutes and 20 minutes for a cycle time, and that's still a wide range. And yeah, it's just
Yeah.
we were learning 3 years ago. We've definitely made adjustments in the way that we use the tool. We have to
Mhm.
have a couple other tools to be able to counteract what we're doing, because we try to look at Takt Time for like a month out
Mhm.
just to verify our demand for a month out. But then it's like, okay, what is truly due within the next week to 2 weeks? Because if we don't stay on that, we could still be late on orders, and that's our only way. But I didn't know if there's any other tricks that maybe you guys have experienced.
The only other thing I would say is if you can get your inventory built to like that vanilla stage that like if you can get some work done ahead of time. But otherwise
Okay.
it's very difficult. Or it's almost like if you take units of measure or units of time within the cycle time and like do everything in 15-minute blocks or an hour block and try to fit it and to fit the total process time in. Do you know what I'm saying? I don't know if I'm saying it very well.
I think so. I'm trying to grasp what you're saying there.
Yeah,
Kind of
so
like
that you
break
can
it down
kind of
to a
mix
smaller
them around
portion.
a little bit.
Yeah.
Because you
And
have
that's
to
what
come
we
up with
try to do with,
something that's standard.
yeah, there's times there's operators running 2 or 3 machines, and we try to at least the way that I've tried to help structure is to group by like cycle times. So at least you could have like,
Exactly.
15 and a 12, is closer than
Yes.
like rerunning a 5-minute and a 25 or something.
Absolutely.
So,
Yeah. Yeah,
okay.
that's what I was thinking, like those blocks of time.
Yep. Okay. All
Um,
right. So similar things of what I'm doing, I think is what you're kind of saying already. So, okay.
Yeah, because you just kind of got to look at your specific application, right? And figure out, let's try this, let's try that.
Yep. Okay. Got it.
But if you
Thanks.
ever want to bounce anything off me, personally, feel free.
Okay. Well, I'll get your information then. I probably will.
Okay.
So,
Happy to help.
Beth, we have a couple other comments. So
Okay.
Sam asks, can working at Takt Time ever compromise quality?
No, nothing ever compromises quality. If you can't make a quality part in Takt Time, then you're out of balance. You can't. The engineers or whoever has to readjust the work content to get you under there. Does that make sense? Is that the answer you wanted? Hopefully.
That certainly fits what I know. Yeah, thank you for confirming that for me. Yes.
Yeah.
There's a comment from Josh. If you can he's commenting on the conversation. If you can accurately project things like setup time, then think about taking that out of your available working time in your Takt calculation. So I'm not sure if he's responding to Ryan's varied work.
I would think that he is. Yeah, like taking an average setup time and that's an interesting idea. Because it's
Yeah,
not your.
I
Go ahead,
have
sorry.
taken that into effect before, and we've tried it, and then it's kind of like thrown us off because like when we're doing Takt Time, usually we're doing it for an area. So it's like our milling area. Well, that's 35 different machines. So
Right.
now
Right.
every one of those, I can kind of do an average, but some take 12 hours, some take 2 hours. And yeah.
Yeah.
Thanks for the idea though. I can try to revisit that now that I've had more experience with it. So
Right. Do you guys have like the opportunity to put cells together, or is everything so
yeah, we've been
random?
getting better at doing cells, and that's also over the last 3 years. We've been able to try to structure products to run through similar product lines before,
Mhm.
and so we've actually within the last year, and now we are actually bringing new equipment in to be able to utilize same parts across multiple pieces of equipment. So you don't have the capacity on the machine of it can only
Yes.
run on this particular
Yes.
machine. So we have
Yes.
tried doing some improvements like that as well.
That's great. I mean, the more you get your flexibility, the easier it'll be to use Takt Time.
Exactly. Yep.
Yeah. Anybody else? Don?
No other questions in the chat, Beth. I think you're okay to move on.
Does anybody have any examples of what they've done that they'd like to share?
What do you mean by that?
Well, besides you, Ryan, you were given some examples, like some other practical things that
Gotcha.
people have learned or tried, or just to share with each other.
I guess one other thing I can share is, okay, so originally when we first started this in 2020, we took it by the area of mill, lathe, so on. Okay. And then we've broken it down because we realized, hey, we were getting late on jobs. Our OTIF was not on time because we were making product and we didn't make the right product. So we had to break it down to that next level of, okay, out of the product family, and we tried to narrow it down to about 5 to 10. Okay, so those 5 to 10 product families, we build a Takt Time for each one of those, and then that's what moves through. So then as demand falls off of one, usually something picks up somewhere else, and we then shift that into its, we call a wheel or, product family. So
Sure.
that was our one thing that we started to learn after about 6 months. So
Absolutely. Product families, separating it is the way to go without a doubt. And then if you can get into cells for those product families, then it's just easier for Takt Time or whatever you're doing it, because you're doing it for that smaller group of products. Anybody else have something they want to share? All right, Don, how about if you share? Oh, go ahead.
Oh, well, I was just going to say, I know you have from class, you had plenty of experiences. And I think Ryan's asking a question that's on a lot of people's minds. When things don't fall, like in this example that I'm showing, when it doesn't fall neatly in a series of events, or the series of events have a complicating factor in the middle, what is do you have a process of thinking? Do you try to make things visual? Like, what are your solving steps? Because I know between your ears, there's a lot of value that I'd like to share with the group to
That's awfully nice. Yeah.
get out. Well, I think I'm the one who made this happen to have you here, and I know you have a lot of value to share. So we've got 10 minutes or so to pick your brain.
Sure. I would say the rule that I violate all the time of like an extreme lean zealot is that I'll put inventory in places where there isn't necessarily inventory right now. And to me, because we don't live in a perfect world, sometimes you have to put that inventory buffer in order to create flow right now and keep everybody working and keep it going in that whatever the timing is. But then you start to work on the processes like, why do we have to have that inventory? Where the Japanese, and I have been part of their like Kaizen events, and they come in and they're like, no, you have to blow up the whole line right now. And as Americans, we're all like, no, 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 we're not going to put our customer in that jeopardy right now. We understand where you're trying to get for us and the passionate pursuit of perfection and everything just going along the way it's supposed to. But we also know that trucks on the road blow tires and all that kind of stuff. So when I first go into an organization, I look to where the inventory is. And that's when, Don, when we took those kids to the production, to the printing factory, that's what I told them to look for as we went through the shop. I was like, look, where is the inventory? Why is it? And find out why it's there. And a lot of it is because, well, this process doesn't run at the same rate as this process. So either this process is going to be starving for work, or we got to put a buffer in, and maybe the one process has to work 2 shifts, and then that process works 1. So the inventory goes up, but then it comes back down again because you're getting it through, or whatever it is. So for me, and like I said, if we have any zealots in the room, putting inventory in, people cringe, and I know it's money and all that, but that's the way that you can see how your process can flow. And then you start working on your setups, your PMs on your equipment, so it's not going down when you don't want it to. You're sharpening your tools more often, all those things that we all know to do. But at least if you stabilize your process first, to me, the company or the customer, it doesn't make them as nervous because they're like, okay, I can see that inventory. Now, as we fix your problems, that inventory can come down. Is that kind of what you're talking about, Don?
Yeah, that's a good example. Right. Like in that example, they had a lot of issues between one workstation and the next. So like as they were packing and mailing, he had an entire conveyor belt that moved things. And so, right, in a lean student sense, I saw the bad lean, the like, let's do lean perfectly. And the reality is you have to meet the world where it's at. And that was super helpful. Yeah. If you want to put up that other slide, it might generate some other thoughts from people. We don't have any other comments in the chat. I know I would encourage the group to ask questions of Beth. She's super talented. So the offering I put up here is a project I was on last year for about 4 months, and these are individual work cells and the developed Takt Time. And I worked with a master black belt to develop this. We were in California. It was a lot of fun to do, and I think the plant folks knew there were issues but couldn't identify it. And I think anybody looking at this would say, gosh, is there an issue and where is it? And it's sort of obvious, right, Beth? I mean,
I think so.
what stands out? Like, is there any question where you need to focus your work? And what's amazing is how simple it was. It was very task oriented and a lot of processing individual units, some timing for cycle time, and there were different steps to get us to this, and then the visualization to make it obvious. Man, that was really, for me, that was super cool. So but this was easy because it was sequential. Like you knew even though they didn't know. So we have some questions popping up. Let's see. Lisa says, at GM in the 90s, management implemented a 0 buffer mandate. It shut the plant down until they figured out the optimal buffers between stations. Lisa, thank you. Yeah.
Yes.
Yeah, I think it's great when people share. What I like about Lean is the transparency. And when you get to people saying, oh yeah, that didn't work, I think that's where we all learn a lot. Ryan's talking about being in a job shop, which is particularly difficult, right? Josh asks, do you have stories that illustrate how Takt Time is used outside of manufacturing? Material distribution business, I would throw in service, I do a lot of office work, and Takt Time is just, it doesn't seem to be visible.
Doesn't seem to be visible. Is that what you said?
Yeah, I mean, I think working in offices, why I like shop floor is because it's obvious, like the parts.
Oh, because you
moving
can
through,
see it, because you can physically
You
see
can
it.
see it.
Yeah.
Yeah, you know, you can't really see emails flying. It takes a little bit extra work. Anyway, so Josh's
Right.
question is, do you have stories that illustrate how Takt Time is used outside of manufacturing? And he says, i.e. material distribution.
Yeah. I can tell you specifically for like design engineering, because the plant that I was telling you about before, that we were machining the parts for plastic injection molding machines, for whatever reason, they decided that they had to create their own. I mean, there were a lot of reasons, but they had to create their own print for every single part. So our backlog or bottleneck started before manufacturing even got the order, because design engineering had to create a print for every single one. So we were able to come up with, like, you know, we need this many prints every day based on the stream of orders that are coming in. And because they're engineers, they designed a whole in the computer process to measure it. And that's okay. I would rather just, you know, stick something up on the wall and say it took me this long today or whatever. But you can use it for stuff like that, or even like order processing. Again, it's hard to see. It's not so visual. But if you know on average you get however many orders a day, then you know how many need to be processed that day. So then you say how many people you have or how long the shift is. But those are the things that are like in the inbox, kind of like Don said. You can't see them. They're not as easy to see the flow. But you all know, you get an email, somebody's asking you for some information for something, and then you have to send that on to somebody else to go to the next step of the process. If you know how many of those orders or whatever are going through the process every week or month or year, you can set up that kind of a metric that says, okay, in order to hit our numbers so that manufacturing can make the part on time, we need to have this many drawings coming out of design engineer every week or whatever it is. So that's a couple. Does that answer your question? Or does that give you the good stories you were looking for?
I would say yes. He's specifically asking a material distribution business. So
Oh,
like my Troy project, Beth, is a warehouse distribution. I could lump it into that.
right.
So Takt
But it's the same,
time for that.
it's the same kind of thing. If you know about how many orders you get, how many pick lists you get a day or a week or a month, it would be an average, of course, and you could measure to that average, and you could say, well, if we're within 10% of that average, we feel good about ourselves. But that's the kind of thing. It's whatever it is that's moving through your process. So in distribution, right, you get the pick list, then you got to go pick it, get it back to shipping, whatever, packaging. So it would be how many orders do you get a day, or how many trucks are coming in a day, or how many packages. But then you have to say, what's an average number of part numbers per order? You have to do a lot of deep dive into your data, but you could, again, think about whatever it is that your final product is, whether it's a drawing or whether it's stuff on a truck to go to the customer or go to the distribution center or whatever it is. What is that process that you're going through, and how often or how many times does you go through that process in a day on average? Does that make sense?
It does to me. Josh
Okay.
says that makes sense. Thanks.
Excellent.
Beth, we're down to 5 minutes. So if you have any final
Okay.
comments, or if you want to review anything, I have a couple closing remarks. So I guess I'll just, well, yeah, go ahead. You make your comments, and then just I'll remind people about
Go ahead. Because
MLC.
I want to ask what everyone liked about today. I want to get the benefits and concerns. So you go ahead first.
Okay, great. So just for everyone that's still on the call, we've had a couple who had to leave. Thank you for participating on the call. Go fill up your coffee and get a chance to connect with Beth on LinkedIn would be my suggestion. And Beth has contact information. She is, I will brag on her. She is a really quality person and can help in just about anything Lean land that you may come across. And she's interactive that way. So Beth, thank you for your time and commitment to presenting to our members and guests. And so yeah, why don't you do your Q&A?
It's been my pleasure. I was talking to Don about this kind of stuff recently, and I said, this is actually where I am in my career. I want to help other people, you know, get through the roadblocks that they're trying to knock down to make the world a better place, a leaner place, to continuous improvement, all that. So my contact number, LinkedIn, all that. Can I? Oh, yes. Yes, I can. Good idea. Now I can't talk and type at the same time. You guys know that, right? Whoops. I'll give you my email too. But if you guys,
great,
if anyone
okay.
has comments on what they liked about today, what they didn't like about today, I know my technology didn't work. What else? For my continuous improvements for the next time that I'm doing this kind of stuff.
Some feedback. I think this was very good for like a definite intro to Takt Time and all that. Like this was very similar to how I learned. And then with the visuals and a little bit of even speaking to like the bomber thing, one, it's interesting. So then you're also going to make things stick, you know? So like having a
Yeah.
cool example like that also helps. Yeah, like I said, I've been doing this for a few years now, and I try to just listen to somebody else just to see if I can take more information out of this one. So, you know, I was able to just pick your brain a tiny bit. One thing that you said, which a couple others didn't say, is like, you know, I think you said the shortest time that you would look at changing Takt Time would be a month. Is that right?
Yes.
So like you wouldn't want to change it any sooner than that. Is that my understanding? Okay. Where
I
I've
wouldn't want to. Right.
Okay, where I've like with other groups that we've been in, they're like, oh, you could potentially be changing it every hour, you know? And
Well,
so,
you could.
yeah, I
but
know it's a
wouldn't
lot of
recommend
work.
it,
It's a
right?
lot of man work, and you know, it's time to put in there. I've tried to figure out our fastest way. We're actually going to go through like a Kaizen here to try to develop a quicker way for our scheduler to pull information and to develop this Takt Time so we can get it potentially even like in a refresh button in Excel, you know? So right now she pulls it and spends 2 hours, you know, doing it for one area. So let's like, how can we reduce that? So,
Right.
okay.
Exactly.
Yep.
Exactly. Sounds like you guys
Yeah,
are doing
thanks.
great stuff.
Yeah, thank you.
Anybody else? Things they liked, things they didn't like? Could do better next time? Well, you're all very nice and quiet.
You've reached perfection, Beth.
I sincerely doubt that. Well, I'm going to give you a couple minutes back in your day then. It's been my pleasure. Again, if I can help anybody, that's what I love to do.
Thanks, Beth.
Thank you.
Thank you, Beth.
Bye. Have a good day.
Thank you, Beth.
There's some items in the chat, Beth, that people are
I'm
saying
watching
thank
them.
you. I was going to
Yeah.
say at this point, you're probably reading them.
Yeah.
You know, we did just a comment, a plug, shameless plug for the annual conference. We did a Gemba walk, manufacturer, and they had Takt Time that they changed every day. I think it was every day, but it was up, big, huge sheet of paper. They had about 6 stations. They were wrapping fans. They were making fan motors. I thought that was really interesting. And you could see in each place and very little, if any, inventory between stations. And that was a way I had not seen it done before. So that was pretty cool.
Absolutely. There's so many different ways you can do everything. And as long as, if the product is relatively standard or the process is relatively standard, you can change it whenever you want. And if your people are cross-trained, which is what somebody asked about, so that they know, oh, if it goes from 20 seconds to 40 seconds, then I go now and I do this instead of what I was doing before. Right?
Say that again.
If your product or your process is relatively standard, and if your people are cross-trained, you can make the jump more frequently, like you're talking about. Because
right.
Right. Okay. Yeah.
Yeah. Yep. Yeah, it's that